Hi, today I'm going to be showing you how to inspect alarms while analyzing code with TrustInSoft. I created a rudimentary demo to show a type of bug that's surprisingly common and embedded in system code. A buffer is allocated here, but the length is computed through multiple functions. The overflow happens when it's finally written and it's nowhere near obvious from the crash location. So let's investigate where this bug is actually coming from. So first of all, I'm going to open RCI, which is Root Cause Investigator. This allows you to understand the code a lot more deeply. Here in the middle, we have what is called disambiguated code. Normalized code is a simplified version of your source code used by the analyzer. It makes all implicit behavior explicit and rewrites the code into simple core constructs without changing its meaning. And your actual code is here on the right, as you can see. So let's find out where user size is coming from and where it's actually uninitialized. I'm going to right click and show defs, which shows up in here. You can also type in the variable you're looking for and click show defs. So let's click here. So within another function, we're seeing that length base compute is coming from process message. So again, let's click here and show defs. Now we can see where user size is actually being derived. So it's getting highlighted here. Let's go ahead, and one way is we could actually go to the definition, or you can show shortcut icons to be able to navigate easier. So let's go ahead and click the go to the definition right here. And you can see, well, very clearly, this is not getting defined. Let's go ahead and put in a random fix and see what happens to the analysis. You are able to allow source code editing right here. Let's go ahead and just increase that size a little bit. And let's just say size is equal to 4. So I'm going to Control S to save, but now we need to reparse and rerun. Uninitialized memory. However, this is a different bug as we had fixed the one above. Now let's go ahead and enable advanced RCI mode, which can also be done in the configuration in order to inspect the alarm. Let's go and click Inspect Alarm here. After inspecting the alarm, we are able to see the call stack, which is another way to help you find that root cause of the bug. Let's move on to a real code example. Here I have TinyCrypt. I already have set up a few analyses. Let's go and test CMAC. And again, we're going to start up the RCI. We see here only one undefined behavior has been shown. You can also, if there's more than one, click here to see a whole list. So here we have assigned overflow. I'm going to go and click on this section of code, which here in the values panel at the bottom, you can see the before and after. So before this line of code would run and after, and you can see the values that this expression would amount to. But let's go ahead and show defs. Again, show defs here is giving us the most recent definitions of the specified expression before and indicated statement and possible locations where that expression could have been given its value. So let's just click and see where exactly this is taking us. So our analyzer is telling us these 3 entries within the key array are giving us the values of, I believe, 43, 40, and 171. Specifically, if you look into this bug further, 171 is the value that is actually causing the overflow, which we are able to find the specific entry within the key array that is causing this. Again, I'm going to enable advanced RCI mode. I'm going to go ahead and inspect the alarm right from here. You can also click the drop down and select the specified alarm. So again, we see the entire call stack and we're able to kind of drill down into each section and find where the bug arises. This call stack very clearly shows us where this bug is arising from the root in this key array, and it is initializing to that 171 that is causing the signed overflow. One last thing I want to show in this demo of RCI is inspecting values. So let's go ahead and say inspect K. Down here, what we've seen before is that you can show defs, but you can also show the occurrences. This allows you to track a term. Right now we're tracking K and see when it is updated. Let's inspect I as well. And again, it shows you more information on a variable. Specifically I, we can see it is written here and here. Hopefully this quick tutorial on RCI helps you track down the root cause of your alarms. We will go over the rest of RCI capabilities in later videos. Thank you for watching this run-through of TrustInSoft's Root Cause Investigator.